This is a video on splitting the bounds. The question states, use a double integral to find the area of the region below y equals 4 minus x squared and above both lines y equals 3x and y equals 0. So I start by sketching these curves. Y equals 4 minus x squared is a parabola, and then I have the line y equals 3x, and y equals 0 is the x-axis. So here's the picture, and I get the region that's bounded by these curves above these two lines and below the parabola. So now let's draw my little man, and I'm going to show the little man walking in two places. So notice that to the left of the y-axis, the little man's feet are on the x-axis. But on the other hand, to the right of the y-axis, the little man's feet are on the curve y equals 3x. So since the feet are on different curves for different parts of this region, we're going to have to split this integral into two pieces. The first piece representing the left of the y-axis, and the second piece representing the right of the y-axis. So for the first piece, the feet are at 0, and the head is on the parabola 4 minus x squared, and the man can walk as far left as -2 and as far right as 0. For the second piece, the feet are on y equals 3x, and the head is at y equals 4 minus x squared, and the little man could walk as far left as 0 and as far right as the intersection of these, which is at x equals 1. So that gives me the double integrals, the integral from -2 to 0, and the integral from 0 to 4 minus x squared of dy dx, plus the integral from 0 to 1 of the integral from 3x to 4 minus x squared dy dx. So now I just integrate each of these. The integral of dy for each of these is just y. So I get the integral from -2 to 0 of y from 0 to 4 minus x squared dx, plus the integral from 0 to 1 of y from 3x to 4 minus x squared dx. So I plug in. Notice when I plug in 0, I just get 0, so it goes away. So for the first integral, I just have the integral from -2 to 0 of 4 minus x squared dx. And for the second integral, I have the integral from 0 to 1 of, I plug in 4 minus x squared for y, and then I plug in 3x for y and subtract. So I get 4 minus x squared minus 3x dx. And now I integrate each of these. The integral of 4 is 4x, and then minus the integral of x squared is 1/3 x cubed, and it goes from -2 to 0, and then plus the integral of 4 is 4x again, minus the integral of x squared is 1/3 x cubed, and then minus the integral of 3x is 3/2 x squared, and that goes from 0 to 1. So finally I plug in the numbers. If I plug in 0, I just get 0, and then I plugged in -2 and subtracted, and also I plugged in 1 over here, and I plugged in 0 and subtracted, and I worked out the arithmetic. It took a bit of work, but what I got was 15/2. So I can conclude that the area of this region, bounded above by the parabola and below by these two lines, is 15/2, or about 7.5. And I'm done with the problem.